Very good morning. We'll start the problems on projection of plane surfaces. So take this problem. An equilateral triangle, basically it is based on the an equilateral triangular lamina of 25 mm sides lies with one of its edge on HP such that the surface of the lamina is inclined to HP 60 degree, the edge on which it rests inclined VP 60 degree. Draw the projections. So this is a problem, okay, the first problem. So here in the last class I explained some of the important points to remember. So in that, according to go with that, okay, first you have to identify the plane. So in this problem the plane is a equilateral triangle, first thing. Second thing, you have to see rest on HP or rest on VP. So this problem is based on rest on HP, so resting on HP. And third thing, you have to identify whether a corner condition or edge condition. So in this problem they given a edge condition, given edge condition. So these three are with respect to the first positions, okay. So first position, these three are very important. First is the type of the plane, second is resting on HP or VP, third is edge condition or corner condition, okay. So here it is an edge condition, resting on HP, equilateral triangle, so that we can easily draw the first position. Come to the second position. Yes, it is resting on HP, so that the second inclination is always with respect to the HP. So here second position inclination is HP, okay, second position is over. And come to the third position. Yes, third position is whether it is a normal method or locus method. So I told in the previous class, if there is any median, okay, or bisector, diagonal, okay, if there is a perpendicular bisector are there, if they given in the problem with respect to the VP, then you have to go with locus method. But here they given the same resting edge is inclined in the third position. So here the resting position is 25 mm in first position, second position also it's same 25 mm, so that we have to go with a normal method. Clear? So third position is normal method, okay. Yes, based on this we have to start the problem. So here it's a triangular lamina. First thing, here you have to write some of the point. So it is of, okay, equilateral triangle, okay, of 25 mm. So it is of so 25 mm, 25 mm, equilateral triangle. First point you have to see. Second thing, it is on HP. Third thing, edge condition, okay. And fourth, HP inclination. How much? HP inclination of 60, so 60 degree. And third, normal method with VP 60 degree. Yes, this is what the problem. Okay, in every problem you have to write like this. First you have to identify which plane, second resting on HP or VP, here it is on HP, and third position edge condition, and in the first position HP and second position inclination to HP we already discussed in our earlier class, and normal method. Okay, yes. So here start constructing. First what you have to do, you have to take a scale and pencil and draw XY line, X and Y. Next you have to show VP and HP. Clear? So this is a first important thing. You have to write XY line, VP, HP. Okay. And first you have to construct a first position. The first position, that is here 25 mm equilateral triangle, and it is on HP, edge condition. Okay, you have to start with top view. Always you have to start with top view if it is on HP. Okay, so construct first triangle with the edge condition. So I will show you manual construction. Okay, I will show you manual construction. Okay, next manual means what you are using with a scale and pencil, how you are going to construct the same thing. With the help of this command I'm going to show the manual way of construction. Edge condition means here the edge should be there left side, so that first draw a line. How much? Length of 25 mm. Okay, next with a scale vertical line of 25 mm we have to draw. Next take a arc, and it is a equilateral, so 25 mm. So from here cut the arc. Take a compass and take 25 mm, cut the arc, and similarly same 25 mm this side also cut the another arc, so that there is an intersection. There is an intersection between this two arc, and this point you have to join. So this is how construction of equilateral triangle and of 25 mm. Okay, these sides also, all the sides are same 25 mm. So this is how you have to construct a equilateral triangle. Okay, with the help of scale, compass and pencil. Clear? Yes. Next, once you draw the top view, you have to name it. You have to give the naming. So here this point is there, second point and third point. In the triangle there are 3 points. If it is a square, 4 points. If it is a rectangle, 4 points. If it is a pentagon, 5 points. Like this you have to give the points name. Okay, this point we can call it as A, this is B, and this is C. We can call it as a C. A, B, C represents the top view. If it is A dash, B dash, C dash, it represents the front view. Okay, so once we finish off the first position, okay, this is with any convenient distance from the XY line. You can take any convenient distance from the XY line. Clear? Okay, so the triangle, equilateral triangle, is placed on the HP. So that it is placed on the HP means placed on the floor. So in the top view it is look like a exact equilateral triangle, but if you see from the front, because it is rest on the HP, so that it is look like a, in the front view it is look like a one single line, and that single line it is on XY line, because you are observing from the front, and that equilateral triangle is on the floor. So if you see from that, it will placed on the XY line. So you have to project for second position. So you have to project all the points to the XY line like this, up to XY line with the help of scale. Okay, project, and this A projected, C projected, as well as this. Okay, then if you join this, these two, it is become an front view. So in the front view it is look like a only a line, because the plane is placed on the HP, so that in the front view it is look like a single line. Then you have to give the name. So the front view I am going to observe. So A is visible. Yes, the A point is visible. So A dash is visible. But in the bracket C dash, because the C dash is not visible. If you see from the front, this A is visible but C is not visible. That's why C dash is in the bracket, and B dash is visible as usual, B dash. Okay. So this is what the representation of a first position. See here in the second position, okay, so HP inclination, here it is resting on HP, so that second position inclination is also HP inclination, and whatever the lamina is placed on the HP, it is 60-degree tilted, and means in the second position you have to tilt that horizontal, means horizontally placed lamina to a 60-degree. So it is with respect to HP 60-degree, means it is appears in VP. I told whatever the angle or distance given for HP, it is appears for VP, and whatever the VP given for HP, means HP given front view dimension and for VP given top view dimension. So here it is HP inclination of 60-degree, means this line is 60-degree. Okay. So in the second position, what you have to do is take any convenient distance, okay, any distance, and you have to draw this line of 60-degree. Clear? So here place, okay, any convenient distance, place it, okay, and this is of 60-degree, okay, and whatever the distance, you just measure from the scale, okay, take the scale and measure the distance, this A dash to B dash, the distance is 21.65 mm, okay, and here what you have to do is, so any convenient distance, place this and draw a line of how much, the line of 21.65, with the help of scale draw the line length 21.65 and angle is 60-degree. Yes, clear? The same line here I tilted because it is tilted to 60-degree. And in the floor, okay, floor means HP, if you tilt 60-degree, it is just look like a line of 60-degree line in the front view. Clear? And if you measure, it should be 60-degree, okay, and the length is 21.65. With the help of scale and protractor, you have to draw the 60-degree line, and this should be any convenient distance, and give the same namings. After that, you have to give the naming, same naming, A dash bracket C dash, it is a fixed point, and in the above is a B dash, okay, it's a rotating point, means one edge, here edge is fixed and that B we are going to tilt it. Clear? This is second position front view, second position front view, and after tilting such a 60-degree, okay, we draw the front view, and after tilting 60-degree, if you see from the top, it is not look like a equilateral triangle, it is become an isosceles triangle, means it look like a isosceles triangle because it is tilted up to 60-degree. So it is not look like a equilateral triangle, it is look like a isosceles triangle, means opposite sides equal. So to get that top view, what you have to do is you have to project the points. See, this is a very important, with the help of scale, okay, take your scale and project points, project the line vertically, okay, here also same thing, project the line vertically, and this line is very thin because these are the projection lines, okay, project the front view downward, as well as here also same thing, you have to project these points, top view points, okay, like this. With the help of scale you have to draw. So here first C is here and C line is here, with the help of scale up to C should be coincide with the C. Next A is here and A line is here. Okay, with the help of scale you have to project, and B is here and B point is here. Clear? With the help of scale and pencil, first draw a vertically this front view towards this top view. Okay, and the top view project right side. Okay, if you draw this C dash should coincide with the C, and A dash should with A, and B dash should with B. Okay, then you have to name this. This is a this intersection is A, this intersection is B, and this intersection is C. And once you got the ABC for the second position, then what you have to do is you have to join this A to B, B to C, C to A. You have to join with the help of scale. Clear? This is a second position top view. I told all the three positions, first position, second position, third position, have a first position top and front view, second position top and front view, third position top and front view. So here we got two positions top and front view. Clear? So we got nearly 4 views, 2 top view, 2 front view, because we got 2 positions. Yes, in the third position, see in the third position, it is normal method. I told it is normal method, and 60 degree to VP. Yes, already we did HP inclination, so last remaining inclination is VP inclination. Okay, and here it is a normal method. Why? Because in the problem they given the edge is resting on HP, means in the equilateral triangle the edge is resting, the same edge is inclined to VP. So the edge distance, you just observe here, the edge distance is 25 in the first position, and in the second position the same edge distance is 25. So in the first position also same 25, second position also same 25. So if the distance is same, then in the third position the inclination with respect to edge is there, so it is normal method. It is normal method. Clear? And I told third position is reconstruction. Okay, third position is it is a reconstruction, means whatever the position we have the top view in the second position, that we are going to reconstruct. So what you have to do is, first you have to draw a line of 60 degree. Okay, the 60 degree is given, the line of 60 degree. You draw a 60 degree a line, and this should be any convenient distance. Okay, take any convenient distance and draw 60 degree line, and we don't know the line length, you just draw a simple line of 60 degree. So next what you have to do is, you have to reconstruct entire thing. This ABC is there in the fourth view, that is what in the top view in the second position, that you have to reconstruct on this XY line, means this entire thing we are going to rotate here. Clear? See here, I will show you this, whatever this thing. Okay, this you have to take this. Okay, and place here. Move option, take here, and you have to place, means entire thing you have to rotate exactly. So like this you have to place. This is what the reconstruction. Okay, so in the software I shown how to replace in the, how to reconstruct in the software, but manually what you have to do is, okay, means whatever the ABC position is there, this triangle, that you have to place on this 60 degree line. Okay, this is what the reconstruction. This is a fifth view, that is what third position top view. So manually first you take a scale. Okay, so I will explain how to construct in manually. Take a scale, this is of 25 mm, and place anywhere Okay, place anywhere of 25 mm. Okay, like this you have to place. To take the scale on 60°, mark 25 mm. So any convenient distance, and mark it as a, this is a C point and this is a point. Clear? Next thing, we need a B point. Okay, so how we are going to get that B point? Yes, with the help of compass. Okay, with the help of compass, what you have to do is, okay, with the help of compass, take a compass and a mark a distance of 16.54. The length of that compass distance is 16.54. Okay, then cut the arc. Similarly, on the point A, 16.54, same distance. Okay, 16.54, same distance, and cut another arc. Okay, so like this you have to cut the arc, then you will get a one point, and that point is, name it as a B. And take a scale and pencil and join the and A to B join. Okay, A to B join, then B to C you have to join. See, like this you have to reconstruct manually, and I already shown how to reconstruct in the software. Just copy, place and rotate. And the last final position is a top view of front view of third position. So for that, what you have to do is you have to project. Okay, once we got one position means second position, by projecting we get the second position. Here also same thing, you have to project this point. This already A dash is projected, it is on XY line, and B dash you have to project. Okay, and this line should be very thin. And next you have to project a point like A. Okay, A is here and you have to project up to A. So A dash is here. Okay, so A dash should be coincide. Next B is here and B is here. Then C is here and C is here. Clear? So like this you have to get the point and name it. This is a B dash and this one is A dash, you have to write, and this is that is A dash, and that is C dash. Okay, because C dash, A dash, B dash. And after, once we got all the points, then join A dash to B dash, B dash to C dash, then C dash to A dash. Okay, so this is a final front view of third position. And once you complete all the positions, then you have to show the arrow mark. This B dash projected like this, this is projected like this, and this is projected upward, and this is projected upward, and here it is downward. Okay, like this you have to show the arrow mark, means projection direction you should show. With the help of pencil, show the arrow mark, means from first position to second position, second to third, third to fourth. So in the introduction class I explained. So this is what the total 6 views. This is the first view, first, second, third, 4, 5, 6. This is a chart we have to follow. Okay, so this is the top view, front view, top view, front view, and this is what reconstruction in the third position. and these thick line represents the visible lines, and all the thin line represents the imaginary lines or projection lines, okay, as well as dimensioning lines. So in this way we have to construct a given problem with the help of scale pencil, and we have to solve the, and we have to get the final problem, final position. This is third position, okay. So say here this is the first position, this is the second position, and this is a third position. Clear? So first position 1/3 marks, second position 1/3 marks, and third position 1/3 marks. If you make any mistakes in the first position, ultimately third position and second position will get wrong. So that first position is important. It's the initial position. That is what the true plane we are going to observe. And second position is inclination to one plane, and third position is inclined to another plane. So here HP is there. So second HP, third VP. And we did normal method because the same edge of a same length, so that same inclination. So it is a normal method.